Hi, welcome to this session in Science Paper 1, particularly which is physics. And of course, we're going to introduce a new topic that is regular in mostly all the exams. In this exam beneficial tutorial, we're simply going to do a topic called radioactivity. And the first part of radioactivity that we're going to do is what we're going to call alpha radiation. So when we talk about radioactivity, I want you to know that this is the release of energy from unstable nucleus of some atoms, and this is for the reason that they should remain stable. So most of the times we can use the word spontaneous. That is to simply mean like something has happened rapidly and has happened huge. So in this case, when we talk about radioactivity, this is the spontaneous emission, or this is the spontaneous release of energy from the unstable nuclei of atoms. And then we've got a question, define the term radioactivity. So here we're going to say a spontaneous release of energy from the unstable nuclei of atoms, or we can say radioactive substances. A spontaneous release of energy from the unstable nuclei of atoms is what scientifically is known as radioactivity. Then B, calcium, which is a 40 and 20, decays by emitting an alpha particle to form Y. What is meant by half-life? So when we talk about half-life, let's give an example of a situation where like a certain radioactive substance has a mass of 30 grams. Then after, let's say, maybe 10 months, it has decayed to about 15 grams. So this is the time that it has taken for it to decay to, that is half of the original mass. So when they say what is meant by half-life, this is the time taken for the radioactive substance to decay to its half of the original mass. This is the time taken for a radioactive substance to decay by half of its original mass. So here we're going to say a time taken for a radioactive substance to decay by half of its original mass. So, like I gave an example, if something has 30 grams, then it decays to 15. As long as 15 is half of 30, the time that it has taken for it to reach 15 from the 30 grams that it originally had is called half-life. So, the time taken for a radioactive substance to decay by half of its original mass is what is simply referred to as radioactivity. Then 2, what is an alpha particle? An alpha particle is a positively charged particle. The reason for saying positively charged particle, so whenever they say an alpha particle, they refer to helium on the periodic table in group 8, which appears with a 4 as well as a 2. And then in this instance, they were trying to say, so here we're going to say a positively charged particle. A positively charged particle. So in this instance, we're now trying to say, write a decay equation of calcium. So to write the decay equation, we're going to write calcium. So calcium in this instance, as we can be able to simply observe, it's going to be 40, and then here it's going to be 20. We're going to put an arrow. They said calcium which is a 40 and 20, decays by emitting an alpha particle. What is an alpha particle? This is the atom of helium. So in this instance, let me just write from here. So a 40 and 20, so this one is going to be a 4 as well as a 2. Then plus, what is it forming? It's forming Y. What should you do? You subtract. So 40 minus 4. This one is going to give us 36. Then 20 minus 2. This one is going to give us 18. Having done that, it simply means we have written a decay equation. What's important is that do not worry about how you're going or what you're going to write. Of course, they are going to give you an element undergoing an emission. Then they'll also give you the exact name or the exact representation of the particle which is going to be formed when it undergoes that particular emission. So calcium is a 40 and a 20. Then it undergoes, that is alpha radiation. Alpha radiation is the atom of helium. So helium, which is a 4 and a 2. So this is 40 minus 4, 20 minus 2. Then of course, this is how to go about it. I hope you find this video very much beneficial for an exam period preparation as well as revision. Till in the next session.